Hello there, I'm Thomas. This is a British American pilot flying the Boeing 777-300ER in tonight's flight from Zurich International Airport. We're going to be overflying Zurich, Switzerland, Germany, and then coming back to the Zurich International Airport, runway 144 Lszh localizer. Landings are on in the cockpit for the pre-takeoff preparation of the PMG simulation Microsoft Flight Simulator X Boeing 777-300ERX. I'm going to start showing you the cockpit instruments, the displays, and functions of the Boeing 777-300ER jet aircraft. I'm gonna start with the primary flight display that displays the airspeed indicated, the airspeed selected from the autopilot and flight director system panel, the ground speed, the magnetic heading and track, the magnetic north pole and true north pole and magnetic variation depending on where we are in the world, the radio altitude above the ground level. We have the barometric altitude above the sea level and the altitude selected from the autopilot and flight director system panel. The barometric pressure of the outside atmosphere, the altitude indicator that displays the pitch ladder in degrees and the bank angle in degrees. Also the Lszh localizer and the flight director for manual guidance of the aircraft, and the autopilot crossbars for automatic guidance of the aircraft. We have the angle of attack of the aircraft as it flies, and also the flight mode annunciator with the autopilot and the auto throttle, later on vertical navigation modes. We have also the navigation display that displays the GPS, the inertial reference position, the terrain map, the weather reflections of the terrain reflections from the weather radar. We can see other airports around aircraft and also other aircraft flying around our own aircraft. Using the transporter, the DXP and ADSC transporter transmitter receiver that transmits our own frequency and receives from other aircraft and calculates this way the other aircraft distance, altitude difference, and also their airspeed and direction. So we can have the display of other traffic in the navigation display using the TICA system and the transporter, the track collision alert system. That also generates the traffic alerts warnings in the primary flight display. And the navigation display, we have also the magnetic heading and track again, the magnetic north pole and true north pole and magnetic variation depending on where we are in the world. You can see also we're gonna create we can see also the airspeed of the wind and the ground speed of the aircraft, and also the next waypoint we're going to be overflying. We have the GPS and also the flight management computer we're going to use to create a flight plan. So we're going to have a complete route displayed in the navigation display. That begins with our original departure airport and runway. We're gonna select the airport and the runway we're gonna use, all the data for the takeoff using the takeoff weight of the aircraft. That includes the empty weight plus the passenger and the cargo, and plus the trip fuel, and plus the reserve fuel, and plus the taxi fuel. And we're gonna select the flap settings for takeoff, and also the horizontal trim stabilizer, the horizontal tail position for takeoff that has been calculated using the minimum aerodynamic accord of the forward wings, and the center of gravity position. This is going to be calculated using the flight management computer. Also, we're going to use the flight management computer to input to select a runway for departure using the departure page from the flight management computer. We're gonna have the seats, the other instruments, departure waypoints and fixes, the intermediate waypoints and fixes, and also the destination airport and runway, and the stars, the standard terminal arrival waypoints and fixes, and the Lszh localizer of the runway we're gonna select for arrival, for horizontal localizer and vertical glide slope guidance. So we're gonna select the runway length, the runway conditions, which is dry, wet, or ice, the wind direction and airspeed, and the barometric pressure, the barometric density, the density of the air, and also the temperature. And we're gonna have the calculations for the takeoff is with the V speeds, the V1, V rotate, and V2, V takeoff. So we're gonna have also, I'm gonna start showing you, while this system, you can see the whereabouts, the cockpits, the Boeing 777. So you can see here is the primary flight display, with the flight mode annunciator, the attitude indicator, and here is the navigation display, and also you can see here is the autopilot and flight director system panel, the upper and the lower ACAS that displays all the engine information and all the systems. It's in the overhead panel, like the electrical, the hydraulic, the fuel on board, the fuel tanks, the pressurizer, and other systems. You can see over here the flight controls, also the landing gear, the wheels. So I'm gonna show you then the flight management computer we're gonna use for creating the route here. Very important for the navigation of the aircraft, also the use of the autopilot, the LNAV and the VNAV, and other functions. Then I'm gonna come to the thrust levers you see here for managing the thrust, and then the flight controls here. You see the yoke, we control the tail, and the ailerons on the spoilers for bank roll, the tail for climb and descent, the horizontal tail, the elevator, and also the rudder pedals for the vertical tail directional controls. You can see both are interconnected. So then I'm gonna come to the autopilot and flight director system panel, the FDS. Now also the autopilot engage and disengage switch, the autothrottle left and autothrottle right engage and disengage switch, the flight director engage and disengage switch, the airspeed selection knob, we're going to select an airspeed for the airspeed guidance of the aircraft in nautical miles per hour, knots, or Mach speed. And we're going to select the modes like the flight level change, the climb continuous, the autothrottle with the speed mode. So we have the fixed thrust modes like the takeoff, go around, and climb mode, in which we use maximum continuous thrust or maximum takeoff thrust, and in which the airspeed is being adjusted by varying how speed the aircraft climbs or descends in terms of trigonometric angle in degrees or vertical rate of climb or descent. You can see also in the vertical speed indicator tape, I forgot to mention here in the primary flight display, we have the vertical speed indicator. So we have also the idle thrust for descent, in which also the airspeed is being adjusted by varying the rate of climb or of descent. And also we have the variable thrust modes, in which the airspeed is being varied by varying the thrust commanded by the engines, while we have the aircraft attitude stable in flight, like in the cruise or the approach and landing. So I'm gonna show you also the thrust levers that command the engine thrust power rating, the N1 or the EPR, the engine power rating. So we have the General Electric G90 turbofan turbojet engines installed in our aircraft, which are jet engines, and they produce a lot of propulsion of thrust. So we have one in the left wing and one in the right wing for symmetrical thrust and redundancy. You can see here the thrust levers we use to move forward or aft and adjust with the thrust. You can see also we'll show you also the upper and the lower ACAS and the indication and controller system display. The thrust levers, how we use the thrust levers to vary the thrust and the airspeed of the aircraft as we fly. Also the flight controls, the horizontal trim stabilizer, the control column and the control wheel, and the rudder pedals, and also the nose wheel steering. So I will show you all the whereabouts of the cockpit. As you can see here, you can see all the views around it. So then I'm gonna talk to you about the Newton's first, second, third law of kinematics of motion, about the nautical and aerospace engineering principles we use also for flying. Then I'm gonna make an engine start demonstration. I'll shut down the engines and restart them, and then set up the flight management computer and make a complete flight from takeoff, climb, cruise, and descent and approach, and not using the Boeing 777-300ER jet aircraft. So thank you very much one more time for joining me. I'm Thomas Hatsios, the British American pilot flying the Boeing 777-300ER in tonight's flight. So we're gonna start now. Showing you all the instruments and the functions of the cockpit. So we have about an hour left for this video to end. So you can see also the outside view of the Boeing 777. So here we have. You can see here is the primary flight display. You can see the airspeed indicated. The airspeed selected from the autopilot and flight director system panel. The ground speed. This is the target airspeed. We have the radio altitude above the ground level 2. We have the magnetic heading and track over here. The barometric pressure of the outside atmosphere 39.92 inches of mercury. The barometric altitude above the sea level 1430 feet above the sea. The target altitude selected from the FTS autopilot and flight director system panel. Here you can see all the values for the airspeed, the heading, the altitude selected. So we have also the flight director with the pitch ladder in decrease and the bank angle in decrease. You can see the pitch altitude of the aircraft 2.5, 5, 7.5, 10, 12.5, 15 over here, 7.5 to 8 degrees of climb or descent, plus and minus, and the bank roll of the aircraft left and right, and also the flight director crossbars or the autopilot crossbars, so the Lszh localizer, also the angle of attack of the aircraft. Here you can see how fast the aircraft climbs or descend, the flight mode annunciator also. So you have here is the vertical speed indicator, the VSI. You can see if the aircraft climbs, the needle moves up above the altitude over here, and when it descends, the needle moves down. So you will see the values increase or decrease. The flight mode annunciator with the autopilot and the auto throttle later on vertical navigation modes. So we can change some values here. We can add the barometric pressure inches of mercury over here, or hectopascals, also the meters for display. We can select also, here you can see we have the auto throttle left and auto throttle right, engage and disengage. So auto throttle left off, you will see auto throttle left off is with yellow. We have only auto throttle right. Now we have both auto throttle off, and now we have auto throttle right off. You see auto throttle right off here. So we have the flight director also off, like this, and on. Disarms all the modes from the flight mode annunciator and the autopilot also. So we have the flight director now. Flight level change, speed, also display of meters, 3050 meters, 10,000 feet, and 436 meters for 1430, and also hectopascals here, 1013 hectopascals. Also we have magnetic north or true north. Now we have the geographic north pole over here, true over here and here. So you can use this switch to change between the true geographic or magnetic, like this, normal or true. So now we have the normal, the magnetic over here, north pole. So you can see the compass is moving a little bit. So now we have also both of the throttles. So This is also depressible, indicated airspeed or Mach, LNAV and VNAV. We can select an airspeed like this. For takeoff and climb, I'm gonna select this also for easier climb. After takeoff, 253 knots. Also, this is the bang angle of the aircraft in cruise, automatic or manual. Heading and track over here, you can see. Heading or track. So we can select the heading of 136 degrees like this. Select and deselect. Climb continues. So if we arm the autopilot, it will change a few modes. Also we have the altitude select, the target altitude we're gonna cruise. So maybe we're gonna make a faster video and flight tonight. So also we can see an aircraft is coming, so you can see different values now. We'll show you the autopilot flight director system panel, also the navigation display. You can see the airports over here, the waypoints we can change. Here is we're gonna have the traffic now, so we're gonna change over here 20 still far away, it's like 10 nautical miles away. So we can see an aircraft is coming. It's 2,700 feet. So you can see the radar scan over here, and also you can see the transporter. We are 10 nautical miles, about 8. Now it's getting closer, so we can see an aircraft is getting closer up to us. Over here is 2,600 feet in front of us, and it's flying in our direction. You can see it over here blinking. So we have we're gonna have it in a couple of minutes. So we have about so we have about 30 more minutes for this video to end. So I will continue with this. The airspeed, the altitude, the vertical speed, my path angle. So you can see here we have heading, flight level change, speed, also 5 nautical miles away, 35,000 feet. You can change that. So we have different modes displayed, but we're gonna have the aircraft flying close to us. Over here is 5 nautical miles away. Now it's getting closer. 4 is plus 1,600 feet, and it's getting down, it's descending, it's plus 1,500. You can see the arrow down, plus 1,400 is descending. So it's 4 nautical miles away. Over here in front of you, you can see using the TCAS system, and we're gonna have the warning in a couple of minutes of the incoming aircraft from the front side. So it's getting lower and lower over here. You can see it's descending, it's approaching. So we can see the warning over here, the radar. Now it's plus 2.5 nautical miles in front of us. So you cannot see closer, but it's plus 800, plus 700 feet now. It's getting down. You can see 5 nautical miles. You can see the range. So we're gonna have the traffic plus 600, plus 500. So we're gonna have it over here, plus 400. Now we see the yellow warning, plus 300, and we have the traffic over here. So we see the aircraft is coming in, it's descending, and it's approaching for landing over here. So we have the warning here in our display. So you can still see the aircraft is descending, and to the left and behind of us, this symbol here. So you can see also terrain elevation, other information. So we lost like 4 or 5 minutes for this. Need to cover up. So we have also auto throttle, autopilot on, heading. So we're gonna have the autopilot on now. Flight level change, speed. We can set also the altitude like this, 35,300 with the autopilot on. And the altitude, you can see also the terrain, the scan from the radar. So we have also the vertical speed of flight path angles. So if we use the flight path angle, you will see a descent, minus 3.5 degrees like this. This is a descending aircraft over here. You will see the pitch ladder. We have the heading hold, flight path angle, this target altitude, but we have to descend. So you will see the purple arrow is marking over here below the horizon line. Also, if we use a climb for the Boeing 777, so we have to move the other way like this. So we have plus 3.5 degrees, for instance. We're gonna have the climb mode here for this target airspeed to this target altitude 35,300, and we have this command pitch altitude for climb over here. So this aircraft is gonna be flying with this pitch altitude during flight path. So a couple more things to see also. The vertical speed, we can select the vertical speed like a descent. We can have the minus over here. You can adjust using this slider up and down like this. Also the heading like this. So we have the minus 3,500 over here. Let's see the descent rate, and we're gonna have also the climb mode, the other side. So you see the plus 3,500 feet per minute, and the climb mode we're gonna have for heading, hold, and vertical speed. And this altitude here, and you can see the purple line over here. We need to climb with this rate, 3,500 feet in the vertical speed indicator. So we can use also the flight level change again. We can disconnect the autopilot like this, moving this switch here. We're gonna have the autopilot disconnected. So we press this out, it disconnects the autopilot. So you can see here the autopilot is on. We press this switch out, you see this warning over here. And the red over here is the autopilot disconnect. So we have to reset that, turn on the autopilot again, pilot on, and we can use this switch here in the control wheel To disconnect the autopilot, press one time. Flight director on, you see the warning, and the autopilot is disconnected again with the red letters over here, autopilot disconnect. So we press one more time the control wheel, this small switch, we press it one more time and it confirms the disconnect action, so it cancels the warning. So now we have to do a couple more things. Talk about the thrust levers, about the systems, the overhead panels. So we have, you can see the thrust levers, so we can use the thrust levers. So you can see here I'll have the flaps up and down, this handle, flaps retract and flaps extend, the speed brakes extend and retract. You can extend the speed brakes only when the thrust levers are at idle position. You cannot extend them otherwise. If you have them extended while the thrust levers are at idle and you move thrust levers forward, the speed brakes retracts automatically. Also, if you move the thrust reversers like this, the speed brakes will gonna extend automatically. So you see the thrust reverse command over here, the reverse. So this will slow down the aircraft in a landing. The thrust reversers and the speed brakes extend during the landing process or in our ejected takeoff. So you can cancel and retract and extend again the thrust reverse. Also, you see from the forward side like this, you see again the thrust reverse, retract the thrust reverse and extend them again like this. So this side, retract and extend again like this. So this is the thrust reverse. You will slow down your aircraft. You don't use it in flight, so you should have them in the forward idle. So we have also the takeoff go around switch here, and over here you have the auto throttle. So this is in the thrust levers. You have the auto throttle disconnect switch over here. You press one time and it disconnects the auto throttle. So you have manual thrust levers like this. Also, you can move one thrust lever at a time. You have differential thrust commanded like this. So now we have one thrust lever forward and one at idle. So you will see the N1 here is increasing for the right engine while the left is idle. So we bring both back to the same position, and also we can use the other side, the left side forward and the other side in a lesser position. You will see again the variable thrust applied like this. Here you have 50% in the left and idle thrust 32 in the right. And just keep it increasing, and we bring both to the same position. Also moving forward for aft, you can see the flaps position. You can see also the arms for takeoff. Go around thrust over here. So you have the takeoff go around, and it arms 104.6% the maximum thrust for takeoff, and also the N1 limit. So you can see the N1 is the low speed starter and shaft, the low pressure compressor and turbine of the turbofan turbocharged engine, the left and the right, the exhaust gas temperature per engine, Some other information not related to the engine and warnings. The landing gear is up and down. Over here you will see later the flaps position, the total fuel on board. So this is for the engine. Also this is the bleeder from the left and right engine, 32 psi, and the cabin pressurization. You can see the Boeing 777 mark here. The N2, which is the high-speed starter, inside the high-pressure compressor and turbine of the left and right engine. 70.2%. The fuel flow per engine per hour in thousands of kilograms or in thousands of pounds. The oil pressure, oil temperature, oil quantity, and the vibration of the N2 stage of the engine. So we're gonna talk now about the thrust levers, about the engines. So we have about 14 and 15 minutes, so we have to talk about the thrust levers and about how you use the takeoff thrust and then make the engine start demonstration. So we have the General Electric 90G90 Turbo Hunter, which is the engine installed in our aircraft. Its engine also contains a gearbox, contains the ITC, the great drive generators. It moves the hydraulic system also, and also the bleeder for the cabin pressurization. Also contains the FADEX. The FADEX are the full authorities, the electronic control computers. One installed per engine, dual engine redundancy. One channel fails, the other takes over. Controls, monitors, and displays all the functions and the data you see about the General Electric 90 Turbo 100 engines. In the upper and the lower display, like the N1, which is the N1 is the low speed starter inside the low pressure compressor and turbine of the Turbo 100 engine, the exhaust gas temperature per engine. The N2, which is the high speed starter inside the high pressure compressor and turbine of the Turbo 100 engine. The fuel flow per engine per hour, thousands of kilograms or in thousands of pounds. The oil pressure, oil temperature, oil quantity, and the vibration of the N2 stage of the engine. Also, the FADEX control the engine start, engine shut down, the fuel metering unit, the oil heat exchangers, sensors, and other data like the pressure inside the engine. If we have an overpressure, we can let the outflow air from the fifth and the ninth stage of the fan blades of the starter, into a higher setting to relieve the overpressure from inside the engine. If we have an under pressure, we can close it down into a lower setting so they can increase the pressure inside the engines. Also, if we climb from the sea level into a higher cruise level, from the sea level all the way up to 20, 30 or 40,000 feet above the sea level, the air pressure, the air density, the oxygen level is half or less than that of the sea level. Also, the temperature of the air is freezing, way below zero, like minus 30, minus 30, minus 40 degrees. Also, the aircraft flies in an airspeed rate 2-3 times faster than that of the sea level. So the air mass intake from the front fan stage is much higher, much faster into the turbofan engine for fuel air mixture. So the engine fuel air mixture also is being controlled by the FADEX. The full authority electronic control computers. So it's a good thing to have the FADEX installed in your engine instead of doing all these things manually. Also, when we descend from the cruise level back to the sea level, we have to adjust again the fuel air mixer. So we'll show you now, we'll talk to you about the takeoff speeds. For this flight we have 254,000 kilograms of takeoff weight, about 521,000 pounds, which is below the maximum takeoff weight. We have about 30% of fuel on board, or 46,000 kilograms, or 102,000 pounds. And also we have about 30,000 kilograms of passenger and cargo, about 46,000 pounds. So we have in total 243,000 kilograms, or 521,000 pounds. So we need to use for this runway that conditions like the runway length, if it is ice, wet or dry, and also the wind direction, speed, and the air density, air temperature, and the pressure of the atmosphere. We need to use 15 degrees of flaps for takeoff and 4 degrees of horizontal trim stabilizer, horizontal tail position for takeoff, and this is being adjusted using the mean aerodynamic chord position calculations for the forward wings in the center of gravity position. So this data is being calculated using the flight management computer automatically. So you can see here, we're gonna show you now in a couple of seconds. So we need to take off for this runway. We're gonna use 154 nautical miles per hour, 154 knots, or 270 kilometers an hour for takeoff. We need to overcome the stall speed. The stall speed is gonna make the aircraft wings stalling up, not produce the necessary lift force that is gonna make the aircraft fly up into the air. The lift force is the force that overcomes the weight of the aircraft. That is equal to the mass times the aircraft acceleration depending on where we are in the world. So I'm going to show you also this. I'm going to show you the aerospace engineering and nautical engineering, and also the Newton's first mechanism of flow, kinematics of motion, and the Bernoulli theory of fluid. And I will talk to you about the flight theory of this aircraft, the Boeing 777-300 ER. So I'm going to start. Now you can see, I'm going to show you also the flight controls. So we have, you can see the wings of the aircraft here. You can see the mean aerodynamic chord position. You can see the aircraft surface area of the wings is holding the aircraft weight in flight. Also, the mean aerodynamic chord position is the position where the maximum aerodynamic lift occurs, or also is where the stall of the aircraft wings begins above the surface, in the top surface of the wings. The flow of the air becomes detached. Also you can see the vectors from the engines from the left and right forward propulsion. You can see also the lever, the center of gravity here, where the mean aerodynamic chord position is, this vector. Also the longitudinal vector from the nose to the tail, and the wingtip to wingtip vectors. And we have the center of gravity to the tail is the moment arm, or the lever arm position. So it's times the distance from the center of gravity all the way back to the horizontal or vertical tail, times the airflow of the air mass per second, times the acceleration of the Earth's gravity. Also you can see the same applies for the ailerons and the spoilers in the left and right wing. Also we have the lift using the Bernoulli theory, fluids, and the Newton's physics. You can see the bottom surface of the wings is more flat, so the airflow of the air mass is moving much slower below the wings, so there is higher air pressure below the wings, which pressurizes the aircraft up into the air when we reach the takeoff airspeed. Also the top surface of the wings, the airflow moves much faster because there is higher curvature above the wings. So using the Bernoulli theory of fluids and the Newton's physics, you can make all these calculations. So now I will show you the flight controls. So I will show you now the flight controls to make the engine start demonstration. So you can see here we have the cockpit, and I have the side stick, the Lszh Extreme 3D here. You can see I'm using for controlling the flight controls like this. So you can see I can move up and down the yoke, so I can climb or I can descend like this. Also make bang rolls left and bang rolls right, and also use the rudder pedals left and right. So you can see both are interconnected, the left and the right side yoke, the control column for the horizontal tail, the elevator, up, climb or descend, and also the ailerons and the spoilers left and right. So you can see the side stick deflection is proportional to the flight controls deflection. Also we have the thrust levers like that, move forward or aft. So we can move the thrust levers, and also this flight controls together. So also we have the horizontal trim, the horizontal elevator trim position like this, pitch up and pitch down. So I hope you like the flight controls. Now I'll show you the outside view of doing the same thing. So you can see here so now I'll show you now the outside view. So you can see here we can move the side stick and the flight controls around, so we can move up and down like this, climb and descend, and barn roll left and barn roll right, and also the rudder pedals left and right. So you can see the other ones in the spoiler. So this is all for the flight controls. Now we'll go inside and show you the overhead panel and make the engine start demonstration. So we have about 13 minutes left for flying, so we need to be a little bit more fast. So you can see the overhead panel, you can see the hydraulic fluid disconnect, some switches here, the circuit breakers, and most of the cockpit inside. So we have to be a little bit more. You can see also over here all the switches. So we need to start the APU, the auxiliary power unit, like this. Also the ADU, the air data and reference unit. You can see all the air data displayed here, like the airspeed, the GPS position, the altitude, the indication. We have the GPS and gyroscopic laser gyroscopes. We have the thrust asymmetry compensator, the primary flight control computers, the electrical system, the left and the right engine produce the backup generators, the battery. This is all the primary system. So we have the passenger oxygen, the window heat, the cargo fire, the electronic engine control for the engines, also the rammer turbine, the hydraulics. We can turn off the hydraulics, you will see what will happen. So we're gonna have some fault by turning off the hydraulic pumps. So you can see the fault coming up. Also the warnings here, because we lost some hydraulic power flights. Brake surge, no to land, hydraulic demand pressure, C1 and C2, CNR. So we have also alternate flaps. The stabilizer is lost, so we need to turn on all these hydraulic pumps again. And then to the auto position after we have them on. You can see this lighting system for the aircraft, the windshield wiper left and right, the ground proximity runway override, the electronic engine control for the engines, normal and alternate, the auto start position on and off, so you can start the engines with these switch. You can dump some fuel to lose weight and make the aircraft lighter for landing if you want. We have the left wing and the right wing fuel tanks, which are balanced, the crossfeed valves, the pressure for the center tanks is empty, there is no fuel. the wing and engine at the eyes like this, on and off. And also the cabin pressurization of the aircraft over here, automatic or manual. We have to use the outflow valves for climb and descent, and select the landing altitude like this. Also the bleeder from the left and the right engine. We're gonna lose many systems. You will see also over here. So this is the bleeder from the left and the right engine. Bleed isolation. So we're gonna have also the hydraulic system C1 and C2 like this. Also no bleeder for cabin pressurization. Also we need the bleeder for wing and engine and the ice, air conditioning and ventilation, and also for starting the engines. We're gonna use this bleeder here. Also I forgot to mention these switches here. I'm gonna show you now. So this is the horizontal trim stabilizer you can use. Over here you will see this is the disconnect for the auto trim. If you have a failure of the autopilot and the auto throttle auto trim function, you can use only the manual over here. So this is the manual trim order for the horizontal tail. Over here you pitch up and pitch down. Also you have the aileron trim, so you can see the ailerons and the rudder trim here. So this is the horizontal tail trim, and this is the disconnect, and this is also the normal in the alternate horizontal tail trim tab. Also the flaps position here, the fuel flow to the left and the right engine, the speed brakes I showed you before, and the fire extinguisher, the left and the right engine, the transporter, the weather radar. So we have many systems. So we go now for starting the engines in a couple of seconds. Only one system left, this display over here. So we have the display on. You will see the engine, the status, you can see the hydraulic source, the APUs running, and the oxygen level, the checklist, normal menu or non-normal if we have a failure of a system, the communication, synoptics. You can see the doors are closed and the cabin can be pressurized, the landing gear. You can see the temperature of the brakes and the pressure of the tires, the electrical left and right engine, the backup generators, the APUs running. So this is the electric charge and discharge, also the voltage of the battery, and the APU battery over here. So also the hydraulic system over here. You can see left engine, right engine, where the hydraulic system fluid goes. 3000 psi left, right engine, and the backup, the demand, the left electric, right electric, and the shut-off valves. So you have also the fuel, the left and the right wing fuel tanks over here. The crossfeed valves between the left and right wings stabilize the fuel level. The center tank is empty with yellow crosses. You can see the low and high pressure fuel valves to the left and the right engine over here. The total fuel on board 101.7 thousand. The APU is fed from the left wing over here using the DC motor. So we have also the forward and the aft pumps, and the minimum fuel temperature below which the fuel freezes. Also we have the air system, the left and the right engine, the APU. If we increase the thrust commanded from the engines, you will see more pressurizer here coming in from the left and the right engine. You can see the engine, the shut-off valves, and the 59 stage. So this is used for hydraulic fluid, the cabin pressurization, wing and engine at the ice, and starting the engine. So the last thing, the flight controls. You can see I can move the flight controls. You can see the horizontal tail position, the vertical tail. All the flight controls are moving. So you can see here I'm having this control like this. Also the other side, and you can see everything here is working. with the flight controls page. There is no failure right now for the flight controls in the hydraulic system. So we close this, the engine again, and we go for the engine start demonstration. We shut down both engines. So we see the overhead panel reset, and also we have the engine shut down, engine auto start, engine shut down over here. And you can see the engine is closing down, auto start left and auto start right. There is also no fuel flow, is zero. So we come outside, you will see both the right and the left engine like this. It's trying to restart because the auto start is on. So you see the spinning, there is only pressurizer, there is no fuel flow yet, it's zero. So we need to start the fuel flow. We are ready. We start both left and right fuel valves like this, and you see here the fuel flow will pop up rapidly, and the exhaust gas temperature and everything. So we have both right and left. The engines are ready for takeoff like this. So one last step left before takeoff. We need to set up the flight management computer like this. So we have the latest menu, as you can see, the model position initialize LSZ8, the reference airport, the route, zero fuel weight, gross weight, reserves 5%. So this is gonna be the calculations for takeoff. 25,300 feet, the takeoff altitude like this, the cost index, the minimum fuel temperature, and the center of gravity for cruise, origin, departure and destination, and departure runway, departure and arrival. We're gonna select this runway, Lszh for departure, this, and arrival, Lszh. Again, Trans-Negri Alpha, Trans-Amity. So we have to clear here the legs of the route. So we activate and execute, and we have the complete route, and we only use the takeoff 15 degrees of flaps, center of gravity automatic, and the takeoff speed with this cross weight and this takeoff. So we have all the route data over here, and the ILS localizer is armed. So we disarm the parking brakes here, and we advance the thrust levers and go for takeoff. So we use also the nose wheel steering like this, and the rudder pedals. So we take the takeoff clearance for takeoff, advance the thrust levers already. So we have the runway is empty. We can only tax into the runway for takeoff. We have taken the runway clearance, align with the center line, using the rudder pedals also for alignment with the center line like this, and the nose wheel steering together. So parking brakes on. So this is a nice view outside where we are and where we're going right now. We're gonna have this view for takeoff. Everything is set. Automatic commands, TLNAV, and we're gonna have the nice scan for the radar. Flaps are set, and horizontal trim stabilizer set. So we advance the thrust levers, the takeoff position, disarm the parking brakes and go, and we have 18 minutes left for this flight. So we need only to 35, 15 degrees, the flap setting for the takeoff. So we have 130 knots, V1, we rotate, and V2, and we take off. So we need also to pitch down a little bit, not climb so swiftly. Landing gear up, we have positive rate of climb. So you can see here we are 1,500 feet above the ground level. The airspeed is 250 knots, the stall speed is close here. 2,500 feet above the ground, 4,300 above the sea level. Keep climbing with 9,000 feet per minute. And this is the pitch altitude, about 20 degrees. Now we have to decrease it to hold to increase the airspeed, not reach the stall margin over here, 150 knots. For this configuration of the aircraft, so we need to start steering also to the side. So here we are, keep climbing, and we have about 16 more minutes left for this video to end. Maximum takeoff thrust. So you can see here is the stall warning, here is our airspeed, and this is our altitude and our rate of climb. So we need to keep climbing and hold a little bit as we keep climbing. 12,000 feet. We have the stall speed, the warning again, you can see 140 knots is the stall, 145 is the warning. So we need to hold the pitch altitude like this as we turn, and we have the runway, and we make a small correction here. So you can see the whole of the Switzerland around us, and the galaxy as we climb. And we have about 15 more minutes for this flight video to end. So I hope you like the view of the Boeing 777. Make bungalow like this. You have this beautiful view, hope you like it. We fly with about 600 kilometers an hour, or 250 meters per second right now. So we had this nicer view, and also to make a turn. As we climb, we're 18,000 feet, and we have 13 more minutes left for this flight. So we need to hold bring down the aircraft a little bit. So we are 20,000 You have the warning for the stall now. So we need to cross the first waypoint you see here. It's the 0 to Alpha. You see the waypoint over here in the primary flight display. So you see display here, we have to cross the waypoints in this thread line looking flight path that has the origin, the airport, and the destination is the same airport, so we have to fly around these waypoints. So we have the modes here all on, then we keep climbing. You can also set to the 9.92 the mercury and excess of mercury or hectopascals. So we keep climbing like this. So we're gonna have this beautiful view here. You can see also the autopilot, the settings, and the thrust here commanded. So we climb through, we have the Germany, the Bayern Munich in front of us as we keep climbing. It picks up a little bit, and we have 12 more minutes. So we have the Bayern Munich in front of us, and the France on this side, and the Switzerland on this side, and now we're gonna have the outside view. We are 34,000, 33,900, 34,000 feet above the sea level, and we climbed to 25,500. We have these beautiful frozen vapors, and we fly with about 600 kilometers an hour or 250 meters per second. You can see also the Germany in front of you, this side, the Bayern Munich, and the France on this side, and the Switzerland, the lakes here. So hope you like the view of the Boeing 777. So this is our spacecraft for tonight, and we are 35,000. And we have 35,300, and we have to start going back into the airport. So we need to hold level here, as you can see, manually hold level, and we need to start making the turn like this manually, bang roll. So we start the bang roll. And we have 9 more minutes left. You can see we hold stable manually like this. This flight altitude 35,300 feet. Also need to increase the airspeed. And retract the flaps. So we have over here, we are flying the lake here. This is our spacecraft for tonight, the Boeing 777-300ER, and we fly very close to the Germany, Bayern Munich area with 900 kilometers an hour, 300 meters per second. With the Boeing 777-300 the airliner. So hope you like it. So we're flying across this spacecraft at night through the galaxy, and we have 9 more minutes for the video to end. Also Zurich, the Germany, the France, the Switzerland. We have this beautiful view. And the galactic view over here. So we're going back to the cockpit. We need to start descending. And we have 7 more minutes left. We can also apply the autopilot on just for display, like this. So we need to come also the next waypoint. Execute. And the landing, the airspeed configuration for landing. So now we have the legs and the airspeed and the flap settings to take for landing over here. And we're flying using the autopilot 35,000, 300 feet, and we have like 6 more minutes left. As you can see, 35,000, 300 feet, 300 meters per second. And this is our spacecraft for tonight. So we need to start descent. We'll select a lower altitude. So we have the idle thrust and the speed brakes extend, and we have 5 more minutes for this flight. So we keep descending, as you can see, 32,000. We have the autopilot on. Over here, we need to decrease the airspeed like this. So we are descending. We have the speed brakes on. Seventeen thousand feet. Keep descending like this. And we have 4 more minutes left. Also, we need to activate the warlock and disarm the autopilot like this. Fly manually and also extend some flaps. And we have 3 more minutes left. So here we are descending to the runway. So we're gonna have a nicer view for this. We have 2 more minutes left. And we are inside the Lszh localizer like this, as you can see. All the information, the vertical glide slope and the runway information. And we have 1.5 more minutes. Also we use manual thrust and manual guidance. So we have manual guidance over here. And we have 1 more minute for the video to end. Idle thrust. So here we are. 10. Touchdown. Reverse thrust. Parking brakes and reverse thrust. Full reverse. So here we are. Just touchdown, parking brakes and full reverse. So you can see also you can see the landing gear here. The nose wheel is perfectly safe. There is no breakage of the nose wheel. It's perfectly safe, and also